Hello, my name is Kendra Kelly, and I'm an upcoming senior in the forensic chemistry major. I've been performing this research project with the Arroyo Research Group in the Department of Forensic and Investigative Sciences at West Virginia University. Hydroxyzine, an antihistamine, is frequently used for its analgesic and anti-anxiety effects for the treatment of allergic and inflammatory reactions. Hydroxyzine is also used in cancer patients in conjunction with opioids, and since it can mimic the analgesic effects of opioids, it is commonly used as a diluent in seized drugs of abuse. This study uses both electrochemistry and spectroelectrochemistry to analyze this drug. The spectroelectrochemical approach provides in situ preparation of a surface-enhanced Raman substrate by electrochemical means to provide improved spectroscopic signal and lower detection limits. The time-resolved process allows for simultaneous data collection from both instruments. The orthogonal combination of electrochemistry and spectroscopy for this drug can provide a rapid, sensitive, and cost-effective detection platform as an alternative to current screening approaches. Initial investigation and electrochemical characterization of hydroxyzine was carried out using both differential pulse voltammetry, or DPV, and square wave voltammetry, or SWV, in a dibasic sodium phosphate solution at pH 9.5, and parameter optimization was carried out for each technique. Once the parameters were optimized, calibration curves were constructed for each method using a range of calibrators for the analyte between 250 and 5,000 parts per billion. A calibration curve for hydroxyzine using spectroelectrochemistry was also constructed between 75 and 1,000 parts per billion. For SWV, the optimization can be seen in Figure 4, demonstrating the importance of parameter optimization. Additionally, Figures 5 and 6 show the voltammograms and resulting calibration curve, demonstrating excellent linearity and low percent RSD. Similar results were observed for the DPV method seen in Figures 7 and 8, again with good linearity and percent RSD. A difference in the voltammogram shape can be noted in both methods between high and low concentrations, where high concentrations demonstrate 2 oxidation peaks. In the low concentrations, only the main oxidation peak can be observed. Raman analysis of the hydroxyzine solid was completed along with an EC-SIR spectrum for comparison. Figure 9 demonstrates the similarity between the Raman bands of interest between two techniques, providing confirmation of the hydroxyzine spectrum using the EC-SIRS method. Figure 10 shows the spectra collected using EC-SIRS for hydroxyzine in concentrations from 75 to 1,000 parts per billion. The calibration curves for the average peak area for peaks at 1089 and 1188 inverse centimeters can be seen in Figures 11 and 12 respectively, with each band providing good linearity and reproducibility. A summary of these results can be seen in Tables 1 through 3. For DPV, the average potential was seen at 0.58 volts, the R-squared value was 0.995, the percent RSD of the slope was 4.7%, and the limit of detection was 181.4 parts per billion. For SWV, the average potential was seen at 0.69 volts, the R-squared value was 0.995, the percent RSD of the slope was 7.4%, and the limit of detection was 255.5 parts per billion. For the spectroelectrochemical analysis, the peak at 1089 inverse centimeters had an R-squared value of 0.994, the percent RSD of the slope was 11.8%, and the limit of detection was 74.2 parts per billion. The peak at 1188 inverse centimeters had an R-squared value of 0.990, the percent RSD of the slope was 7.1%, and the limit of detection was 105.4 parts per billion. These results demonstrate promising limits of detection and approaches for analysis of this drug. In summary, the analysis of hydroxyzine using electrochemical and spectroelectrochemical methods was demonstrated to be achievable for seized drug scenarios. The methods showed low limits of detection, R-squared values greater than 0.99, and percent RSD values less than 12%. Orthogonal detection between the two methods provided improved reliability and sensitivity of this drug. Future work will focus on analyzing simulated seized drug samples, improving the limits of detection, and investigating the electrochemical oxidation process. The authors would like to acknowledge that this project was sponsored by the National Institute of Justice. The opinions, findings, and conclusions are those of the authors and do not necessarily reflect those of the Department of Justice. Thank you.